Okay, so today's problem is 131 palindrome partitioning. So what I need to do is to split this word into parts, partition it into parts so that every part is a palindrome. Okay. So code, where is the code? Let me reload that. Okay, code is here. So how this task can be solved actually? So if I have this input string, let's say I have this input string, and as input I have, let's say I have AAB, and then I'll this is the input. So I'll start with empty string, and I will gradually move the pointer from left to right. And on every move, I need to decide if I gonna continue the current string or not. So initially I have A, then I can have AA, and then I can have AB, and then on every step I can break and start again. So here, so let's have this, say I have this one, then I'll start here, and then I'll start the third part gonna be B. So A, A, B, or I can have this A, A, B, or I can have A, A, B, or I can have the whole word A, A, B. And on every step I need to check if a new candidate is a palindrome, so single letter is a palindrome, and A single letter is also a palindrome, and B is also a single letter is a palindrome, so this should be included into the input as into the output. So A, double A, and then B, this is the valid output. That's A, B, and then I'll check if A again, on the second one. This one, first candidate, second, third, and fourth. So A is a palindrome, but AB is not palindrome, so this is not included. And AA is a palindrome and B is a palindrome, so I include this one, AA and B, into the result. And AAB is not a palindrome, so I don't include that one. So the question is how to efficiently figure out if the current part is a palindrome or not. And usually this can be done, let's say I have string with a length, let's say M, and I need to check if is palindrome, and let's say it starts at S and ends at E, and then E minus S plus 1 equal M in this case. So is palindrome this S, a string that starts at S and ends at E, equal if char at S equals char at E, and if is palindrome a substring that starts at S plus 1 and ends with e minus 1. So if those two conditions are true, then is palindrome is also true. And the trivial case, like if there s if s equals e, then it's palindrome. Is palindrome equals true, and otherwise, if it's not equal, is palindrome gonna be equals false. So drawing the BT tree here, as I said, I start with the empty array, and initially I is at 0, and then I decide if I gonna go, if I gonna complete the part or if I continue the part. So initially I have 3 because I have input string as A, B. So initially I have A, and then I can have AA, and then I can have AAB. And I check if the AAB is a palindrome. It is not, so I didn't continue. And next, let's say I continue with A is a palindrome, double A is also a palindrome. So I continue with A, and I now I is equal 1. So I start candidates with I equals 1. So I can have A comma A here, or I can have A and comma AB. And the same here, I start with I equals 2 in this case. So I equals 2, and I have only one option, it's A comma B. And continue here. Here I is equal 2, also have only one option, AA and then B. So here I came to the end. Here came to the end. Here came to the end. Check if this is a palindrome. The last one is not palindrome, so the whole branch is not palindrome. And here I check if the last part is a palindrome. It is. So this should be included in the output. And this one also is a palindrome. The last part is a palindrome. So this one also should be included into the output. Okay, so in order to efficiently check if the word is a palindrome, let's say I'm gonna have the dp two-dimensional matrix, and let's say I'm gonna have a b word, so it's gonna be 3 by 3, so len, and it's gonna be len string by len string size. So if it's gonna be len by len size, in this case it's gonna be a 3 by 3 matrix. And on the row I'm gonna have start indexes, so 0, 1, 2, and on the column I'm gonna have end indexes, 0, 1. So start and end gonna be inclusive. So end 0, 1, and 2. And here on diagonal is gonna be always and this gonna be Boolean matrix, and the dp of SE gonna mean that if a string in if substring at S and E inclusive is palindrome, and if it is, then it can be true, else it's gonna be false. So here the char that starts at 0 ends at 0, so I have this one. Chart that starts at 0 and ends at 0 is A, so it's a palindrome, so here it's gonna be true. Chart that starts at 1 and ends at 1, it's also A here, so it's gonna be also true here. Cell at 1, 1. And chart that starts at 2 and ends at 2, it's a B, it's also palindrome. Next, I'm gonna derive all the values that are higher than the diagonal, because those values that are lower than diagonal, they basically starts at 1, and if substring starts at 1 and ends at 0, it's basically empty set, so it doesn't exist here. So I need to check for the string that starts at 0 and ends at 1. Starts at 0, ends at 1. So we need to check if it's palindrome, and how to do that, I need to take start and then characters and compare them. So I need to char 0 and check with char 1. And also I need to check the middle part, but because they are next to each other, the middle part is string of the length 0, it's like just empty string. So by default, empty string is a palindrome. So here I need to just to check 0 and 1, and 0 and 1, so chart 0a, chart 1a, so they are equal. So this one should be true. A string that starts at 0 ends at 1 is also a palindrome. So here the same, you need to check chart 1 and chart 2, a not equal b, middle part is empty string, so here gonna be false. And then I need to check the final one to fill up this matrix. Substring, or like substring that starts at 0, and ends at 2. And for that one, I need to check char at 0 equals, if it's equal to char at 2. And also I need to check is palindrome. So string that starts at s plus 1, so here 1, and ends with e minus 1, so 1, 1, if it's a palindrome. So let's check first if it's a palindrome, like chart that something that starts at 1 and ends at 1. Here, like a is palindrome, so this one is true. Check mark here. If char at 0 is equal to char at 2, char at 0 is a, and it's not equal to char at 2, it's b here. So here should be false. Yeah, that's the way how to fill up this matrix. So the first step, fill up the matrix, this DP matrix, and then the second step is traverse the tree, and like kind of quickly check if the current part of the substring, if the current if the last part of the of the string is a palindrome. If yes, then proceed. If no, then like stop proceeding with this branch. And as soon as I reach the end of the string, and if this is kind of valid partitioning, all the parts were valid, because otherwise you would stop branching. So just add this candidate to the output array. In this case, it would be like 2 candidates. They're all both gonna be added to the output array. So if I'm gonna start the coding here, so first I'm gonna create a matrix for this is palindrome checks. So it's gonna be in Boolean. Let's say start with n, int n equals. So talking about time complexity for this algorithm, so I need to fill up this matrix. So it's gonna be n squared time complexity, and then I need to go backtrack, and then this backtracking. So on every level, it's gonna be on the first level. It's gonna be n minus 1. Oh no, it's gonna be n operations. So we're gonna take like one, then gonna take a substring that's as a first part as a candidate substring like 2 of length 2, 3, and then so on and so forth. N, and it's gonna be n operations. And then on the first level, gonna be n ops. And for the every ops, I go to the DP array and check if it's palindrome. If it's yes, if it's palindrome, then I'm gonna record that as a candidate. If no, I will just exit. On the second level, I'll have n minus 1 ops. On the third, n minus 2 operations. And the fourth, and so on and so forth. On the nth level, I'm gonna have like one operation. So the one operation is gonna be here, like it's gonna be like a single chars partitioning, and there are like n of those like single chars. So it's gonna be just one operation. I need to add the final character in a string to the output, and kind of, yeah, that's gonna be the palindrome. So like if I add all this n's, so it's gonna be n plus 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 1, and gonna be n times. So if I add this one together, it's gonna be the n plus 1 multiplied by n over 2. So the total time complexity for creating DP array, DP gonna be O of n squared, and then for the actually BT part, backtracking, it's also gonna be O of n squared. So it's gonna be total time complexity gonna be O of n squared, and space complexity time, and space gonna be also O of n squared because I need to save this matrix, DP matrix. So start creating this DP matrix. I have about like 3 minutes to do that. So string.length, and then I'm gonna have DP array equal new integer like boolean, and by n, and then I'll start filling up with a diagonal, so like in diagonal number d, and then I'm gonna start like all the diagonals there. Okay. So if talking about this algorithm that I'm gonna use, so I'm gonna start with diagonal, like I'm gonna start filling like this values on diagonal, and then I move this one gonna be d equals 0. The next diagonal gonna be d equals 1. Let's use d equals 1. So it's gonna be next diagonal elements, and then the last one gonna be d equals 2, and it's gonna be the last element. So I'll keep iterating by diagonals, and then I will derive e and j, and on every diagonal, let's say on diagonal 0, I'm gonna have like n internal iterations. On the diagonal 1, I'm gonna have n minus 1 iterations, n iterations, iterations. And here I'm gonna have like on the last one, I'm gonna have 1 iteration. And on every kind of iteration, I need to derive e and y, e and j, and fill up like dp on I and j, if it's like true or false. So if I go to the back to the to this IDE, so I start with diagonals until the d is less than n, d plus plus, and then I go for int I equals 0, and then I less than I minus d, like n minus d, and then I plus plus. And then in this case, what's the column number gonna be? So the column number gonna be int j gonna be so I need to do this, so it's gonna be d plus I. Yeah, d plus I, and then I'm gonna check dp of ij should be equal case if I plus 1 less than j minus 1, then I need to go dp I plus 1 j minus 1, else true. So this is gonna be like true on the diagonal. And then I need also to check char str char at I is equal to char at j. So this is the filling of the DP array. So next one gonna be private avoid BT, and it's gonna be int start, and it's gonna have this boolean DP array, and then I'm gonna have list of, let's say, int coordinates later, and then I'm gonna have list of string as an output. So, and let's say I create the list of the string as the output equals new array list, and then I call bt starting from 0, then I pass dp array, I create a new array list as accumulator, and then I pass the output, and I finally need to return output. And for the bt, I need to check if the start index is actually equal to the say, and also I need to pass the n. Yep. Or I actually can derive n on the dp.int n equals dp.length. And if f is equal n, then I'll need to create the candidate for the output and add that candidate to the output. So list string like list equals new array list, and then for int I equals 0, I less than let's say accumulate. Let's say we have like this coordinates in the accumulator. I'm gonna have this list dot add, and then okay, I still need the string because I need substring operation. Str dot length str dot substring, and then I need to pass the coordinate start index, and then coordinate end index, but +1 because it's exclusive. And then I will let's say, because I can add iteratively, so I will do this linked list, and I don't need to resize this, so I need to output just add list and then return. And then for int I equals s, and then until I less than like if I less than n I plus plus. I'm gonna do this. I need to check if the if the substring that start um, at s and ends at I, if it's like actually if it's palindrome. So check if si if it's palindrome, then I'll do this accumulator.add new integer coordinates and s and I, and then I'll do bt s plus 1 dp accumulator output and string, and then I need to remove the last one. Remove from accumulator size -1. That's it. Linked list, remove last. Okay, I need to just remove last. Let's say I want to have linked list. Linked list, new linked list here. And probably here I also want to have linked list, because I don't want to optimize for like resizes. Like I don't wanna like have resizes of the array, take some time complexity. So remove last. This should be it. This is the condition for the exit. If the current part, or like current partitioning, the last part of the current partitioning, if it's not palindrome, I'm gonna just not proceed, and just move to other branch, and then eventually this path is gonna be removed like on upper level. So I'll try to run this one. Byj new boolean, and okay, I need to have two-dimensional dp. Get string here. Okay, and I need to pass also string here. Still not true if s is equal d. Okay, let's say list of list. Okay. Hmm. So what I wanna print here to debug, I wanna have this for int I equals 0, I less than n, I plus plus, for int I equals and yot equals 0, yot less than n, yot plus plus. Here I wanna do that system out print dp I yot plus comma, and then system out println dash n to check if I'm doing that correctly. So here, like I have like false, true, 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 false. That sounds like right DP matrix. So the question is here. Why I add this A and B here? Accumulator. I need to do this I plus 1, okay. I plus 1 and yeah, that one should be better. Yeah, but still kind of. Yeah, I wonder why this is not that great from the performance wise. We're gonna do this deck. Hmm. Okay, let's say I have array list here, a new array list. I didn't prove much. Yeah, going to wrap up. Let me check what they have, what they really have. So this is a similar algorithm is palindrome substrings. So pre-calculating seems like pre-calculating this one is okay. Okay, pre-calculating string seems like helps. Let's try it. Palindromes p strings as new string like n and then if dpi yacht true, then p strings ij and I have this string and p strings I start and if add so coordinates coordinate 0 coordinate 1 will be better. Yeah, a little bit. If I change here linked list linked list. Yeah, still not that good. Seems like this check palindrome function works faster. I guess it's because it's palindrome. I don't know why. Let's check. Yeah, really. Okay, whatever. I'm gonna wrap up. Yeah, so this is failed because I didn't check. I didn't find that the problem, that issue with that index on time, I guess. So I didn't like this probably. Like I was adding s plus one instead of I plus one, and that was the problem. Um, so I need to go like next iteration of backtracking need to start after the current partition part.